GPT-Researcher is an amazing tool for doing comprehensive online research on a given topic. So in this tutorial, we're going to create a simplified version of GPT-Researcher using the new LlamaIndex workflows. The GitHub repository for the project will be linked down in the description. First, let's look at the demo of Llama-Researcher. We run the script, passing in the main topic as the command line argument. We can see that first, it breaks down the main topic into subqueries, then uses Tavily to search for contents on those subtopics, then gathers and processes them, finally creates the final report and opens it. This is the final report it generated from the topic that we gave. We can see that in different sections, it's using references to the source where it got that content from. At the end of the report, we can see that it listed every single sources that it used during the research. Let's look at the high-level architecture. It's quite similar to what we have in GPT-Researcher, but simplified. So first we get the main topic to research, and from that we create a list of subtopics that we're going to use to search the internet. And for that purpose, we're going to use the Tavily API. So for each of the subquery, we send them to the Tavily API, and from the result that we get back, we create a list of LlamaIndex documents. Then we clean and chunk them up and create a LlamaIndex vector store retriever. And from the retriever, once we get the nodes, we use similarity PostProcessor from LlamaIndex to filter out the nodes that are not so relevant to our corresponding subquery based on a similarity cutoff. Now we get the filter nodes for all the subtopics, which we then combine and create the final prompt for generating the reports. From the prompt using the LLM, we create the final report. Now let's look at the code. We can see that this is the workflow for the research assistant. It takes in the LLM to use and the embed model for vector embedding. We get the topic from the command line argument, and we pass in the topic and call the run function. If we look at the workflow, we can see that in the constructor, it sets the LLM embed model and initializes the visited URLs as an empty set. So it will make sure that we do not have duplicate contents from the same URL across different subqueries. So we can see that the start event triggers this step, which is the first step that creates the subqueries from the main topic. So we can see that we use the LLM to get the subqueries, and we save the total number of subqueries as a variable in the global context, which we will use later when we are combining the results from all the subqueries. So we can see that this step fires the next event, which is the subqueries created event. This event calls the next step that goes through each of the subqueries and triggers the process subquery event for each of them. So we can see that the process subquery event calls this step where we get the documents for each of the subqueries. We can see that we use Tavily API, passing in the subquery to perform the search, and from the results that we get back, we create a list of LlamaIndex documents. And when we send the results back to this function, we trigger the next event, which is the document scraped event that calls the next step function, which is to compress the documents. We can see that we call this getCompressedContext function, passing in the subquery and the documents that we got from Tavily in the previous step. In this function, we can see that we create a LlamaIndex VectorStoreIndex from the documents. We specify the transformations we would want on those documents. In this case, we just use a sentence splitter to chunk the documents. And then once we get the nodes from the retriever, we apply the similarity PostProcessor. This will ensure that the nodes whose similarity score is lower than the cutoff is filtered out. For this, we are setting 0.38 as the cutoff, which is same as GPT-Researcher. So now from the filtered nodes, we create the context specifying the source, the title, and the content of the node itself. It triggers the next event, which is to combine the context event. Now this event, we can see that it uses the collect events function from the global context to wait for the context from all the subqueries to be ready. So this is where we use the number of subqueries that we saved earlier. Once all the context from all the subqueries are ready, it goes through each of those events for all the subqueries and creates the combined context. and we pass that combined context to the next event, which is the report prompt created event. Now this event runs the next step, which is to write the report. So we can see that it calls generate reports from context command, passing in the main query and the combined context from all the subqueries. So if we go to the function, we can see that this is the prompt that we use. The prompt is same as the prompt used in GPT-Researcher. So once we get the report from the LLM, we write that report to the PDF file and call the stop event. So after the workflow is done, we just try to open the final report file. So we can improve on a few areas here. For example, I would like to add parallelism for processing the subqueries, and we can also add multi-agent support so that multiple agents can work on generating different parts of the report, similar to what GPT-Researcher has. So that was it. Hope you enjoyed the tutorial. Thanks for watching.